Have you ever seen an online spinning wheel? They look somehow fake. There's no smudging happening between the colors like what you see in real life. Think about the color wheel. If you spin it fast enough, all colors actually blend into one. But online ones tend to look like this. So in this video, I'll teach you a simple technique to code a more realistic effect. Get your editor ready for a spin. Get it? Because no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
I'm writing using Visual Studio Code, and in an empty folder, I'm creating a new file, index.html. So we can begin with basic HTML syntax. First, the doc type, then the HTML tag. Let's also close it. And inside we have the head section. And let's give a title to the page, spinning wheel. Okay, and in the body, we are going to add one canvas element for now. And let's save this. And if we open index.html in a web browser, I'm using Google Chrome, you can see the title appearing here, and the canvas is also here somewhere, but we need to open the developer tools and check it inside of this elements section if we want to see it, because it's transparent at the moment. We can fix this by giving it a quick style. I'm just going to give it a border that is solid so we can see it. And now it appears on the page as well. But I want to make it bigger so it covers more of my available space here. And I'm going to just go here beneath and add a width of 700 pixels and a height of 700 pixels. Now save and refresh, and the canvas is all this available space now. To draw on the canvas, we need to address it somehow, and I'm going to give it an ID of my canvas. And now below here, let's begin a script tag. And in it, I will get a reference to the canvas context like this, and we will use this object to draw things on it. Let's begin by drawing a circle. I like to take things easy, so a spinning wheel looks like a circle, and let's see what it takes to do that. We need the center, and I'm just going to use the canvas width divided by 2 and the canvas height divided by 2 and the radius. I like to use things relative to the canvas like this, so let's just make it 40% of the canvas width. That means we still have something on the side that is not painted. And let's begin to draw a circle by remembering how the arc method works. So first it needs the x and the y, and then the radius. So now we also need two more things here, because this arc method can draw incomplete circles, like fractions of a circle as well. We need to specify the start angle, 0, and the end angle, 2 pi, because 2 pi means 360 degrees, so a full circle, and it needs to be in radians, this other way of measuring angles. Now let's fill, save the file, and refresh to see our circle appearing there. Okay, now we want to be able to slice this circle up somehow, kind of like a pizza. we would benefit from having a kind of a object here that does that for us so that we don't complicate the logic in this file here too much. And the number of colors that we will be using there should be a parameter. I think the colors themselves should be a parameter. So let's try to think in those terms now and define here colors. Maybe let's use default ones like red, green, and blue. And I would like this wheel object to be defined like so, using the center location and the radius and also those colors. It makes sense. And then the code here just draws it using this CTX object. So the code stays nice here, and the responsibility for how the wheel should look like moves to a new object, which we need to implement. So I'm going to go up here and prepare to write this object in a new file, wheel.js. And let's close this script tag. And now control clicking this in Visual Studio Code creates a new file for me next to index.html. So in it, we can implement our wheel class. The constructor has 3 parameters: the center, radius, and the colors. And let's set these so that the wheel knows where it is, how big it is, and which colors it should contain. And now that the draw method, given the context, we need to figure out how many slices it has. We don't really need to figure it out. We just take the length of this colors array, and that's how many there will be. In this case, 3, because we have the red, green, and blue color selection there. And now to draw those slices, we are going to loop from 0 to the slice count, like so. And we have to figure out the angle, the start angle and the end angle for each slice. We won't be using those 0 and 2 pi values there anymore. We will be using this start angle and the end angle. The start angle relative to 2 pi is going to be given to us by this percent. So I divided by the slice count is going to give us a value between 0 and 1, and we multiply that by the total number of radians available there. And we do the same thing for the end angle, but it's going to be where the slice ends, and that's also where the next slice begins. So I'm going to put here I plus 1 divided by the slice count. And now, similar as before, we can begin the path, and let's move to the center point. And then arc to the center X, center Y, using the radius, and now the start angle and the end angle. We can set the fill style to this colors of I and fill. This is almost the same thing we had as before, and if we save and refresh, we can see this end result appearing here. The only difference in the code is really this move to. If you take it out and restart, you're gonna get this, because the arc is just filled from its starting location to the end location. But if you move to the center point here first, and then draw the arc starting from whatever angle and at the end, by default, this fill is going to also fill this remaining gap here. So that's why those pi slices are appearing there. Let's put this move to back there. And this is what we're now working with. Next step being let's animate it so that it spins. And you can do this in many ways. You could have the wheel have an angle, and it can even have a speed for moving, and that's fine. You can play with structuring this in a better way. But I'm just going to give the draw method the possibility to draw it at a different angle. Maybe pi. So this will be offset by half a circle. And if we add here to both of these the angle, like so, and save, we can see going back here, and when I refresh the page, red moved here because previously it was starting in this location, and now it's offset by half a circle. So it works. To animate, we can go to index.html. Maybe after we have the wheel here, let's remove this drawing for now. And we will start it at angle of 0. And this is going to be the property that changes during the animation loop. So our animation loop is going to look like this. It increases the angle by a small amount and then draws it with this angle as the second parameter. And then request animation frame is going to call animate again and again and again, many times per second. Now, if we save this and refresh, we are getting this. And this is a typical spinning wheel implementation that you find online. And let's make it a little bit nicer by adding a slider here so we can control the speed. I'm going to go above this canvas and add here an input. Let's also close it. And then here it will be of type range. So a slider. I will give it an ID. I'll just call it speed. And the value, it's going to be 0.1 in the beginning, same as what we are increasing here at the moment. And the minimum value, let's set it to 0, and a maximum of 6.2832, and so on. This is 2 pi, basically. And let's increase this by a small step, like so, whenever we drag the slider. Now, here we have to update to increase the angle based on that speed, but we should also cast it to be a number. Otherwise, this speed value will come in string format, and plus will mean concatenating strings, so appending things instead of actual addition. Now, with this in place, save and refresh, and now the slider here can control the speed of the spinning wheel. And if you go all the way to the end, it actually looks like it's stopped, but it's not. It's just moving on each frame, so it does one full revolution there. And this is a kind of effect that you see sometimes in the real world. You kind of see spinning wheels, like maybe in a car, that look like they're standing still, even though you know that they are moving quite fast. Sometimes even turning backwards. Like here, it goes forwards, but now it kind of looks like going backwards just before stopping again. But one problem I have with this implementation is that I always see these straight lines there. So how to make these lines smudge is one of the problems I have with this. And one way to do that is to go here and add a global alpha of maybe 0.5. Simple as that. And now when we refresh the page, you can see kind of a smudge effect happening there. Now, if we take a kind of a screenshot by pausing this application, and I'm going to do that by typing debugger here in the developer tools, you can see this kind of gradient appearing here. It still appears as kind of straight bands, straight lines here, which is a little bit annoying, but there is some kind of mixture happening between the colors. And I think this is more realistic already. And if we don't do this, like if this is just drawn as before and we stop, each frame is just this perfect straight line appearing there. So the reason this global alpha works is that everything that is going to be drawn is going to be slightly transparent. And then when many things are overlapping, they become opaque. But as the thing is moving, some of the green, for example, is going to be overlapped by the same green color, and again the same green color and the same green color, so it becomes an opaque value of green. But close to the borders here, it's going to have that kind of red creeping in, so to speak. And sometimes it's going to creep just a little bit, but sometimes 2 times it overlaps, and so on. So the end result here, when we pause and look at it, is different levels of overlap there with transparency. Now, to get rid of this kind of band effect, you actually have to use even a lower value for the opacity and interpolate between these a lot, like draw many, many different ones if you want this to look smooth in real. We could do that by going here and saying between the previous angle, between the last angle that we had, and the current angle, I want to draw this wheel multiple times. So let's have a reference to this last angle, like so. And now we do have the last angle and this updated angle to work with. So we can write a for loop where A starts at last angle and goes until angle, and now we just increase it by a very small fraction like this. And here we can close this and align. And also remember to pass here A instead of angle so that it works with this new variable we implemented. And now if we save and refresh, this looks a little bit different than before. If I'm going to pause it, you can see a little bit of a fuzziness here around the borders already. But without decreasing this value by a lot, we won't see it significantly affecting it. So let's lower it like so. And now it looks kind of like a real smudge is happening there. And this smudge goes away when we stop the wheel, but not immediately. So it still lingers a little bit in your vision. And I think this is maybe a little bit too much, but definitely more realistic than what we had previously. I like it. And you can somehow see now those colors blending a little bit. It's very realistic if you consider building a color wheel like this. And actually, if you think about the pixel values, red here is maximum red, blue is maximum blue, but this green isn't maximum green. We could go here where defining the colors and replacing with lime, which is actually the maximum amount of green for those pixels. And when we refresh now, this is the maximum value of green that we have there. If these colors start to overlap, we might see some new colors appearing there. Like now, maybe you can identify while it's spinning these magenta, cyan, and yellow because of the overlap. Now, this looks already much better, I think, and we can do a little bit more testing. What if we try different colors, more colors this time, and we could define the rainbow. So, kind of. At least this Roy G. Biv. So red, orange, yellow, green, blue, indigo, and violet. And I'm really not sure how these color names reflect to what you actually see in the rainbow, because this now looks like so. And I think that some of these colors are not proper. But anyway, let's see how this one looks when spinning. And I can definitely get behind this. Like, I can buy that this is a actual moving spinning wheel, and increasing the speed even more. Make some new colors appearing there, and it even grays out like this. Like, if you watch spinning wheels like this, you will see similar patterns appearing in them. And you can play more also with this transparency amount. Lower values let the colors blend even more, like this. And you can play with the colors themselves if you want. Like, I really don't know if this is the best selection to get that kind of whitish, grayish effect, but it looks much more convincing than what we would have without this smudging effect here. One thing that's also interesting to try is can you implement the same effect as in one of these fidget spinners? Like, it doesn't look exactly, it doesn't look at all like what I'm seeing here in the real world because the camera has some kind of artifacts. But basically what I see here is like a solid disc almost. I just see a transparent disc, maybe like if it would be made of transparent plastic. And yeah, now it's slowing down for real, but spinning it a lot, I just see it completely transparent, and because it's somehow blinking a little bit, I can tell it's spinning, but it doesn't look at all like what you see there. Can we reproduce this effect? Oh, and now you actually see it changing direction, but it's this artifact that we are noticing. So we could try implementing these colors and see what happens here. So maybe going to the colors and writing blue and then white and then white. And let's just copy these 2 more times, save, and refresh. And this is what we get. So we have this when stopped, and when it starts to spin, it's really convincing, I think. I mean, just remember how it looked like before doing this. Let's have a quick look here. Just remove this global alpha. And this is what we had previously. I'm not getting anything near to what we had in the previous simulation. Okay, hope you liked this. Thanks for watching and see you guys.